Hello guys, welcome back to my channel Algorithm Avenue. In our previous video, we have discussed about the entire roadmap of neural network optimization. Okay, now in this video, we'll be discussing our first hyperparameter, that is number of epochs. Okay, in this video, we'll be basically going with 3-point agenda. Okay, our first point is how do we actually randomly set this epoch values, and the second point is what's the actual problem of setting this random number of epoch values, and the third is what is the solution to this problem. Okay, now let's proceed with our first point agenda. Okay, our first point agenda is how do we actually set this epoch values. Okay, now to understand this we basically need to see four cases. Okay, our first case is less amount of data, less data, and smaller model. Okay, in case when we have less amount of data and our model is smaller, let's say we have 100 rows of data and our model is around uh, one layer neural network. Okay, it's a just single layer neural network. In this case we need more number of epochs. Okay, more epochs. Yes, now in our second case, for less data and larger model, okay, larger model, we need less number of epochs. Okay, less epochs. Now let's see our third case. In our third case we have more amount of data. Okay, more amount of data and larger model. In this case we basically need less number of epochs, right? Now in my fourth case I'll be having more data and smaller model. In this case I'll be having more number of epochs. Okay, generally while building our neural network or while building any project we basically encounter these four cases. Okay, in our first case we'll be having less amount of data and corresponding model is smaller, so in this case we'll be setting more number of epochs, means we give more time for our model to learn. Okay, in the second case we have smaller amount of data and our model is larger enough to learn faster, so we set less number of epochs. Okay, in our third case we have more amount of data and our correspondingly our model is very much bigger, so in this case we need less number of epochs. Okay, means our model is able to train itself with less number of epochs. Okay, now in my fourth case I have large amount of data and smaller model. Okay, corresponding to large amount of data and the model is smaller, so in this case I require more training time, means more training time corresponds to more number of epochs. Okay, basically we face this four cases while building our neural networks. Okay, now in this case, okay, in this four cases when you observe, I'm not specifying any particular numerical value. Okay, I'm not specifying any particular numerical value, I'm just saying that more number of epochs. Okay, more number of epochs means how many number of epochs. Okay, just we are specifying that more number of epochs, so more number of epochs corresponds to more number of random epochs. So in this case, in these four cases you are setting your epoch value as random value. Okay, you're basically setting your epoch value as random value. Okay, now in our next section of the video we'll be discussing what is the problem of setting the random number of epochs. Okay, now let's basically discuss the problem of setting random number of epoch values. Okay, problems. We basically face two problems due to random number of epochs. Okay, my first problem is overfitting. Okay, this is the biggest problem that we face due to this number of epochs. Okay, now to understand this overfitting I'll be explaining you with an example. Okay, let's say we have taken a smaller model. Okay, let's say we have a small amount of data and corresponding to that small amount of data I have taken a larger model for training. Okay, now in this case I have set 100 epochs. Okay, I have set 100 epochs. Now around, now let's say around 70 epochs, 70 epochs I have got around 98% training accuracy. Okay, around 70 epochs I got around 98% training accuracy and 60% test accuracy. Okay, 60% test accuracy. Now you need to run more 30 epochs. Now to run more 30 epochs. Okay, after running more 30 epochs, at the 100th epoch, I got around 100% test accuracy. Sorry, training accuracy. 100% train accuracy. But my test accuracy is around 65%. Okay, at 70th epoch, I got around 98% training accuracy and 60% test accuracy. Now, by running more 30 epochs, that is still 100th epoch, I got around 100% test accuracy. Sorry, training accuracy. Okay, 100% training accuracy means your model is fitting very much well on the training data, but it's unable to fit well on the test data. Means it is unable to generalize well on the test data. Okay, this is the case of overfitting in number of epochs. Okay, now let us see our second problem, that is training time. Okay, now to understand this second problem, let us take the same scenario. Okay, let us take the same scenario where around 70 epochs have got around 98% training accuracy. Okay, same 98% training accuracy and 60% test accuracy. Now, to get 100% training accuracy, do I actually require more 30 epochs? Okay, do I need 30 epochs for 2% training accuracy? Okay, no, right? Now, around 80 epochs, I may get 100% training accuracy. Okay, and around 65% test accuracy. So more 20 epochs, I'm unnecessarily training my model, right? Okay, more 20 epochs, I'm unnecessarily training my model. Okay, due to this, what's actually happening? My training time is increasing. Okay, my training time is increasing. Okay, due to unnecessary running of my extra epochs, my training time is being increased. Okay, this is basically my second problem. Okay, now in the next section of the video, let's basically discuss this both problems in detail through code.
Let's basically see how these two problems are occurred during the model training. Okay, first to understand those two problems, I have imported my necessary libraries. Okay, these are my necessary libraries and this is my dataset, that is MakeBlobs dataset. Okay, in my X I am storing my features and in Y I am storing my labels. Okay, I have considered around 10,000 samples. Okay, means I have 10,000 rows of data and 3 features, means it's an 3-dimensional data, right? Now in my X, okay, in my X I have features. Those features are in numpy arrays, so I am converting from numpy to tensors. Similar goes with the Y as well. Okay, now I am plotting my dataset. Okay, this dataset has 3 labels, so I have got 3 clusters. Okay, one is blue, red and yellow, right? Now I am splitting my data into training and testing. Okay, in training I am putting around 80% of the data, and in testing I am putting around 20% of the data. Okay, here I am building my model. I am building a 2-layered model. Okay, one with input layer and hidden layer and output layer. In the hidden layer I am considering 10 hidden units. Okay, now I am considering my loss function as cross entropy loss function, because I am working on multi-class classification problem. I will be considering an cross entropy loss function, and my optimizer is Adam optimizer with learning rate around 0.001. Okay, this is my accuracy function. Okay, I am setting my epoch value as 3000. Okay, why did I actually choose this epoch value so large is I am choosing a larger dataset. Okay, corresponding to that larger dataset, I have built a smaller model. So I need more amount of training. Okay, I need more time for training. So for that I have set 3000 epochs. Okay, this is my training loop and this is my testing loop. Now at the very first epoch, my training accuracy is around 69.6625 and test accuracy is around 66.0. Okay, now when my training goes further, at the 697th epoch, okay, at the 697th epoch, my training accuracy is around 992875. But around 690th epoch, my training accuracy is around 99275. Okay, you see that there is a decrease of 0.01%. Right, there is a decrease of 0.01%, means rest of the training from the 690th epoch is unnecessary. Okay, till 697th epoch I have got around best accuracy, but the rest of the training of 2300 epochs is unnecessary. Okay, means due to this unnecessary training, what's happening? My train time is being increased. Okay, this is basically the problem we face due to setting of random number of epochs. Now in the next section of the video, we'll be discussing an clear-cut solution.
Till our previous section of the video, we have discussed the problems that are faced due to setting the random number of epochs. Now, in this section of the video, we'll be discussing the solution that can counter these two problems. Okay, solution. The solution to these two problems is early stopping. Okay, early stopping. Now, let us discuss this procedural implementation of early stopping. Okay, procedural implementation. Okay, first initially you set random number of epochs. Okay, you set random number of epochs. Now how do we actually set this random number of epochs is you set some higher value of epoch. Okay, let's say around 2000 or 3000. Okay, in this way you set larger value of the epoch. Okay, now in the second step, comparison of accuracy or loss. Okay, now in this step what actually happens is, let's say your model has started the training. At the initial first epoch you have got around 28% accuracy. Okay, your accuracy is 28% and loss is around let's say 2.6. Okay, loss is around 2.6. Now as further training goes on, at the 27th epoch, okay, at the 27th epoch I have got around 98% accuracy. 98% accuracy and loss is around 0.16. Okay, this is my accuracy and this is my loss. Now if you are implementing early stopping basing on accuracy, you take accuracy as your measurement metric, or if you are implementing your early stopping on loss, you take loss as your measurement metric. Okay, now I'll be showing you basing on accuracy as my measurement. Now, at the 27th epoch, I have got around 98% accuracy. Similarly, at the 28th epoch, I have got the same 98% accuracy. Okay. Now, what early stopping actually does is it compares the current accuracy with the previous accuracy. Okay, it compares the current accuracy with the previous accuracy. If it finds no change in the current accuracy and the previous accuracy, your training will be stopped. Okay, if not, your training will continue. Okay, your training will continue. Okay, this is the basic concept of early stopping. Okay, what early stopping does, it measures the current accuracy and the previous accuracy. If there is no change, if there is no change, the training will be stopped at that point. Okay, the 28th epoch is your final epoch value corresponding to the data and model. Okay, now if you are measuring on loss, if you are measuring on amount of loss, you measure current epoch loss and previous epoch loss. If there is no change, your training will be stopped. Okay, this is basically the concept of early stopping. Now in the next section of the video, let's see the code implementation of early stopping on our data set.
Now let's basically implement early stopping on the same dataset and same model. Okay, this is my early stopping class and I'm implementing a early stopping concept on the validation loss. Okay, I'm considering validation loss as my metric. Okay, means my current epoch validation loss and previous epoch validation loss must be differed by some value. Okay, else my training will be stopped. Okay, else my training will be stopped. Okay, here I am building my model and this is my loss function, that is cross entropy loss function, and this is my Adam optimizer, and I'm setting my hyperparameters to the early stopping over here. Okay, I have given specified min delta is equal to 0.001. It is nothing but my previous validation loss and current validation loss must be differed by minimum of 0.001. Okay, I'm specifying that minimum. Okay, minimum. Okay, it can be any number but minimum should be 0.001. Okay, I have given the epochs as 3000 epochs, and this is my training loop and this is my testing loop. Here I'm implementing early stopping. Now when you go through the results, you see that around 483rd epoch my training has been stopped. Okay, my training has been stopped means my at the my validation loss at the 484 epoch and 483rd epoch is not differed by 0.001, means it is minimum, than 0. It is less than 0.001. So my training is stopped at the 484th epoch. Okay, means my best hyperparameter value, my for that corresponding data and model is 484. Okay, 484 is my epoch value. Okay, I'll be sharing this entire code snippet in the description. You can experiment on this. Okay, hope you like this video. If you like the video, please like, share and subscribe. Thank you.